Bonjour. Welcome to Wahsa Education Center's radio Zoom classes. This is MBF3C, grade 11 college math, and I'm the teacher, Bronwyn Slate. If you'd like to participate live today, you can call the Wahsa studio at 1-800-465-7144 or 737-4017. You can listen on the radio at 91.9 FM and also on the television at Bell Express View Channel 972. You're always welcome to join me live through the Zoom link, which is available both from me, your teacher, and also your DEC. Our classes are scheduled Monday through Thursday from 10 until 11 in the morning. We are in our 8th week of our 9-week course. So at this point, you definitely should be submitting work for marking. So a reminder that the support questions, the ones with a little pencil icon, are practice problems. They are not for marking. You can decide which ones and how many to do. If you're understanding a concept, it's totally okay to skip questions. Strongly encourage you to do some and check your answers in the back of the book to make sure that you're on the right track. But you know what is best for how you're spending your time, so you do what is best for you. The key questions, however, the ones with the little key icon, are the mark questions, and these ones you need to do all of them. I'm marking them all, so please do them all. Show all your work, your steps, your thinking. This way I can understand what it is that you understand, and I can give you support if there's something that you're making a consistent mistake on. So how do you submit your work for marking? Well, there's 3 methods. The first is to scan your work and send it electronically. You can scan your completed work using a device. Apple devices have the Notes app, and Android devices have the Google Drive app. They're fairly straightforward point and click scan functions. But on my YouTube channel, I have tech tutorials that walk you through step by step how to actually use these apps, and you can find a lot of help there. If you need more support, let me know and I'm happy to help you. Then you can send your work to email to studentwork@nnec.on.ca and CC to bronwyn.slate@nnec.on.ca, or you could send it through Facebook Messenger to bslate Wahsa. Our second method is to drop it off into Lookout. We have an outdoor mailbox at our location 74 Front Street with a bright red building next to the post office and have a small white mailbox next to our side entrance. So you can just put your work in there anytime and I'll get it back to you as soon as I can. The third method is to hand your work into your DEC. Your DEC can either send your work through the Express or fax it to 807-737-1732 or toll-free fax to 1-800-463-7852. If you'd like to connect with me through social media, both my Facebook and my YouTube channel are under the name bslate Wahsa. All of our radio Zoom classes are recorded and I upload them to YouTube shortly after broadcasting. Everything is there under a playlist called MBF3C. So it's a really easy way to find all of our previous lessons. As well, there are short videos that explain common errors and confusing concepts. So if you're struggling with anything, this is a good place to go and check out first before doing a general internet search. Math is a really visual subject, so I strongly encourage you to access the videos as this is going to set you up for the most success. Either watching on Zoom, you don't have to talk to me, you can just watch on Zoom, that is fine. Or watching the YouTube videos on your own time also is a great option. If neither of those work for you and you would like a copy of the videos, just let me know and I'm happy to send you a set of the recordings so you still can get the full experience and set yourself up for success. So if you have any questions or concerns, please reach out and connect with me. Send me an email to bronwyn.slate@nnec.on.ca. Connect with me through Facebook at bslate Wahsa. Call me at 807-737-1488, extension 2209, or toll free 1-800-667-3703. My office hours are Monday through Friday, 8 a.m. to 2 p.m. Though I teach from 9 to 11, so that is not a good time to try to get a hold of me. Today is lesson 18, and we are looking at data distributions. So our learning goals are that at the end of this lesson, you will be able to create a histogram, and you'll be able to identify common distributions of data. you know you've met these learning goals because you can create a histogram using intervals and frequency tables, and you can explain the differences between normal, bimodal, skewed left, and skewed right distributions. When we'll use this in real life? Well, looking at patterns in math helps us better understand the world around us. Our world is full of patterns. This is how we make connections. So today's lesson, we're practicing looking at those patterns, which may show up in real life, but also just developing that skill is super important. But first, let's activate our brain with some mental math. I don't believe in Mad Math Minutes. They cause stress and anxiety and don't generally teach anybody anything. So instead, we work on developing strategies that you can use in various situations and build your own confidence. Our question today is 742 divided by 26, and we're using the strategy of partial quotients. This strategy looks like long division, but is using logic opposed to just following a set of algorithms. So I really like this because my brain works okay with the algorithm, but this just makes more sense to me. So we're going to think about, instead of thinking about the numbers individually, we're going to think about them as a whole. So how many friendly groups of 26 is less than 742? Well, I can see that 10 groups is less. I don't have to figure out the biggest groups. I just need to figure a friendly group amount. So that's 260. So that means I can organize 260 things into 10 groups of 26, and I've already dealt with them. So then what do I have left? Well, 742 take away 260. Well, 700 take away 200 is 500. 540 take away 60 is going to be 480. So 482 is how much we have left over. I can still see that I have enough to make another group of 10. Sorry, another 10 groups. So now I'm left with 262. Sorry, not 262, 222. So I don't have enough to make another 10 groups, but I do have enough to make 5 groups because I can see that I have almost 260, so that's going to be enough to make half. So half of 260 is 130. So then I'm going to subtract 130 from 222. So $200 take away 100 is 100. Then we have 122 take away 30. So that's going to be 92. So then I can see, well, I don't have another 5 groups, but 26 is really close to 30, and 30 plus 30 plus 30 is 90. So I think that I know I have 3 groups. So 3 groups of 26. Well, 3 groups of 30 is 90, and that's an extra 12 because 26 plus 4 is how I get to 30. So I had an extra 4 each time. So that's an extra 12. So that means that it's going to be, so 90 take away 12 is going to be 78. So, because 3 groups of 26 is 78. So 78, 92 take away 78, 78, I'm going to count up, plus 2 is 80, plus 10 is 90, plus 2 is 92, so that's 14. So I can't make any more groups of 26. So I have a total of 28 groups with 14 remainder. And that's how we use partial quotients. All right, what prior learning do we need to know today for data? I just want to talk about what does data do, and in what ways does it matter the most to us? So data for us identifies the relationship between 2 variables. It allows for the prediction of future and forecasting based on the previous trend of data, so we can sort of make judgments about what's likely to happen. Patterns can be determined in data sets, which gives us information. It can also detect fraud and anomalies, so things that are outside of the common trends can give us information as well. And I want to look at frequency tables. So how frequency tables tells us the number of times an event or a value occurs. And we're going to use tally marks, which are just these little hashes. So every little hash, 1, 2, 3, 4, and then across is the 5th. So each little one counts as 1. The whole group where you have 4 and 1 across counts as 5. So it just makes it really easy to count as we go. Okay, so let's look at putting the pieces all together. This histograms and the data is something that shows up all the way around us. So I've collected 4 different graphs that we're going to look at more these types in more detail, but just so that we can sort of see. So these are all histograms. Our first histogram looks at the distribution of NFL players' retirement age. So we can see that the majority, the average of folks who retire from the NFL retire around 33. There are some people who retire earlier than that, and some people who retire later than that, but that is our distribution. Then we have the second one where we have 2 sort of that same bumps in our distributions where we're looking at test scores, and we have a bunch of people who did study. You can see that they got higher values, but they're still distributed around 80 and 90. Some got better, some got worse, but mostly they got in there. Whereas the folks who didn't study, they got between 20 and 30% consistently, with some people a little bit better and some people a little bit worse. Then we can look at this third graph down here where we have yearly income in thousands of dollars. And we can see that most people make between $20,000 and $30,000 roughly a year, with less and less people making more and more and more than that. And then finally, this fourth one, looking at deaths in Australia in the year 2012, we can see that generally people die in Australia in their 80s, a few people living longer than that, and significantly less people dying earlier than that. Most people die in their older years. So there's all sorts of different ways that we can interpret this data and that we can show different information using histograms. So we're going to look at distribution of data, and this typically takes into account the range and spread of the data set, and it's usually represented in histograms and dot plots is what we're going to be looking at. So a histogram is on page 14 of your IEL booklet, and this is a graph using bars to represent frequency distribution. So the bar height shows the frequency, and there's no spaces between the bars because it's continuous data. So here is an image that shows an example. So this is the number of visits to the library. The number of students that visit once is 4, twice is 5, 3 times is 8, 4 times is 9, 5 times is 3, 6 times is 1. And then we can see that that shows up on our histogram. So when we're creating a histogram, generally we use intervals. So we have an example where we have a bunch of data for the finishing times of marathon runners. So we have all these pieces of data that range from around 1 hour and a half to around 4.5 hours. And what we're going to do is we're going to collect our information and gather it together in order to not have each of these individual points be one data piece, but to put them in intervals. So when we're making a histogram, our first step is to organize our data into a frequency table. So how often do we have data in these intervals? So I've set our intervals to be half-an-hour intervals, actually 29 minutes, so that each point can't fall into 2 intervals. So we have an hour and a half to an hour and 59 minutes, then 2 hours to 29 minutes, 2.5 hours to 59 minutes, 3 hours to 329 minutes, 3:30 to 3:59, 4 hours to 4:29, and then 4.5 hours and over. So then how we organize the information is that we take each piece of data and we tally it. So I'm going through and I count, I find all the ones that fall into our first interval, and I put a tally for each one of them, and I cross them off so that I don't have to look at them again. And then I do that for the second interval. And then I do that for the third interval. And then I just continue to track it until I find all of our pieces of information have fit in one of the intervals. And then our frequency is I just count the tally marks so that I have a number to represent. The tally just is gathering the information. The frequency tells me now I have a piece of a data set point that I can use to make a histogram. So then our second step is to choose our axes on our histogram. So we're going to have an X and a Y axis. Our time intervals are on our X axis. I like to put from 0 and use all of the proper intervals. If you're not going to use 0, you can start earlier on your interval, but you want to make sure that your intervals are the same size, right? Because we're talking about things at the same size. And label your axes so that I know that we're talking about time intervals in hours. And then my y-axis is my frequency. And again, I put all of my points. Even if I don't have any frequencies of 4, I still put that on my scale. Otherwise, I'm skewing my information and it's incorrect. So our scales must be consistent. That is super important. They don't have to be consistent with each other, but they need to be consistent within themselves. Then step 3 is to plot the frequencies in bars that touch. So I had 8 in 130 to 159. So I put a bar that goes up to 8. And then the next interval, there was 2. The next interval was 2. The next interval was 2. The next interval was 0, so I don't have anything. And then I have 1 for 4 to 4.5 hours, and 3 in 4.5 hours and over. And so now we have histogram. And that's what you do. So now you can do the support questions on page 15, question number 1. And that's how you make a histogram. Just those 3 steps. Okay, so now we're going to look at common distributions and like actually analyzing that information opposed to just drawing it and creating it. The first distribution is the normal distribution, and this is on page 16 of your IL booklet. So this is when you have a true symmetric distribution of data. It isn't always perfectly symmetrical. It can generally have a normal distribution feel, even if it's not perfectly symmetrical. But this is when your mean, median, and mode are all the same and together at the center of your data, and then everything falls away symmetrically from that point on both sides. Generally, it's unimodal, so that means that it has one highest point. This is what's called the bell curve that you may have heard about, that people talk about often, just sort of in pop culture. Our second distribution type is bimodal, also on page 16. So this is when your data has 2 peaks, 2 highest points. So your frequencies are clustered around 2 modes. It can be symmetrical or it might not be. So even though technically you don't have 2 modes if they're not the same, but sometimes you have a bimodal distribution where you're clustered around 2 sort of higher peaks. So you're going to have two modes, or even if they're not exactly the same, two that are your higher frequencies. Then skewed left distribution is when it's like your normal distribution, but has been pushed away from the left. I always struggle with these left and right, skewed left and skewed right, because they're opposite way that my brain wants to think about them. That might not be true for you. But the idea is that the information is clustered away from the name. So if it's skewed left, then our higher information is on the right. If skewed right, then our higher information is on the left. So it has a tail, and that's the left side of the distribution for skewed left. It also could be known as negatively skewed for skewed left, because our information is less on the negative side. Our mean is less than our median, which is less than our mode, which can be useful. So then our skewed right distribution is going to be the opposite. So again, it's like a normal distribution, but it has been pushed away from the right. There's a tail on the right side of the distribution. That's where the less information is, or like less data points. And it's known as positively skewed because it has less information on the positive end, on the higher end. And our mean is greater than our median, which is greater than our mode. And then finally, I just wanted to mention uniform distribution. This isn't in your IEL booklet, but I think it's important to just sort of understand. And then uniform distribution is when you have very consistent data. So it doesn't necessarily mean that it's all exactly the same, but as you can see on this graph, your frequencies are around a similar amount. And so there aren't any high peaks or low peaks. Everything is roughly around the same amount, and it's uniform, is why it's called uniform. All right, so now you can do the support questions on page 17, questions 2 and 3. So let's do some practice questions together to see how we actually use this information. So number 1, identify each type of distribution. So again, this is one of those situations where being able to see my screen is really important. So we have adult weight in kilograms, and we have 11 people between 50 and 55, 13 people in 55 to 60, 9 people in 60 to 65, 5 people in 65 to 70, and 3 people in 70 to 75. So we drive sort of a rough curve to see. We can see that we have a tail on the right side. So that means that this is going to be right skewed, or skewed right. Because that's where our tail is, our information is pushed to the left. Here, for school days in each month, we can see that our information size, we have some higher points and some lower points, but generally everything is kind of clustered around like 17 or 18 days. So I would say this is uniform. Next, we have a class marks. Now here we have we kind of have a uniform distribution. It's not exactly in the middle, but it is close. Personally, I want to call this normal because it's fairly symmetrical. Even though it shifted a little bit to the right, I still think that this is more normal than skewed left. You might be able to argue differently. Again, if you can justify it, I'll accept it. And then here I have casino winnings, and I have a high amount in the 0 to 100 and a low amount in the 10,000 range. So here again, our information is shifted, pushed to the left. It's away from the right. So it is skewed right again. So our first one and our last one were both skewed right. They look similar, but also different. So that can happen, is that they can both fall into the same amount, the same classification, but be slightly different. And that's totally okay. All right, number 2. The pulses of 30 people were taken for 1 minute and recorded. These are the results. And I have a big long list of data points. I'm not going to read them all out. They're ranging from about 50 to about 90-ish. We're going to have to organize the information once we get going. So part A says, why is it hard to spot the trends in this data as it appears? So the same reason why I don't want to read it all out is that a list doesn't show us any patterns. So it's really hard to gather any information. Kind of overwhelming for our mind's eye. All right, part B. So we need to construct a histogram. So the first thing we need to do is to get our intervals and tally our information. So I'm going to say, I don't think I see anything below 50. So I'm going to say 50 is our lowest. And I'm going to say, let's go up in intervals of 4, because I feel like intervals of 9 is going to be too big. So we have 50 to 54, 55 to 59, 60 to 64, 65 to 69, 70 to 74, 75 to 79, 80 to 84, 85 to 89, and then 90 to 94. I think, and we can adjust if we need to. Sorry that it got squished at the bottom. So then for this one, what I'm going to do is I'm going to start from the beginning and I'm going to cross it off and then put a tally mark in the right place. It's not the way that I did it last time, but this is just a way to keep myself organized. 76 goes in this one, another 76, 67, 64. So as you can see, organizing your data is an important step. 2, 6, 67, 77, 91, 61. And again, of course, if you did pick different intervals, it's going to be slightly different. That's fine. 86, 73, 87, 61, 67, 71, 81, 86, 62, 77, 51, 72, 68. Okay, so there we go. We have created a tally. So then I'm just going to do frequency. You can see once we have our tally, doing our frequency is pretty easy. Then we need to create a graph. So we have our axes. Because I'm doing this freehand, it is not going to be beautiful. You try to use a ruler, graph paper, something that keeps your intervals even, your line straight. I'm just winging it, and hopefully it's about making sense opposed to being perfect. So frequency, and this is our pulse. So my first interval, 50 to 55, I have 1. In 55 to 59, 55 to 60, I have 1. In 60 to 65, I have 3. 65 to 70, I have 5. In 70 to 75, I have 5 again. In 75 to 80, I have 5. In 80 to 85, I have 4. 85 to 90, I have 3. In 90 to 95, I have 3 as well. So again, a rough sketch, but we see the idea. So now we're going to analyze it. So using our graph to answer each question, in which interval does the most common pulse occur? So we have in the intervals 65, 70, 70 to 75, and 75 to 80 all have 5 frequencies. Had we done our intervals differently, our answer would be differently. That's fine. In which interval does the least common pulse occur? So we're just going to be looking at the intervals that we have opposed to ones higher or lower. So in 50 to 55 and 55 to 60, both had 1. So we're just counting those ones. We're not going to count the ones that were outside that had 0. If there had been a frequency in the middle that had 0, then we would count that interval because there was data on either side of it. But because we don't have any data below it or above it, we're not going to count the ones that are 0 that fall outside of our range. Okay. Number 3. Score out of 100 on a college entrance exam are shown. What type of distribution fits this data? So we have the tally, we just need to do the frequency. So here we have 10, 15, 17, 10, 20, 25, 26, 10, 20, 30, 35, 10, 20, 30, 40, 43, 10, 20, 30, 31, 10, 15, 19. So here, if we do again a rough sketch. We're just sketching it. I'm not even going to draw the intervals or the frequency. I'm just going to say, okay, well, this one was 10. This, well, I'll draw the frequency is the bottom. Okay. And then we had 17. Then we had 26. Then we had 35. Then we had 43. And then we had 31. And then we had 19. So obviously my chart is pretty bad, but we can see, to me, this looks like it's skewed left. Because most of our information is gathered on the right side, pushed away from the left side for higher score values. The measures of central tendency are given for 3 data sets. Identify the distribution for the data set explained. So A, our mean is 7, our mode is 10, our median is 9. So our mean is less than our median, which is less than our mode. So that means that our highest point of our is going to be over here, and then it's going to be skewed like that. So that is, yes, left skewed. B, mean is 21, mode is 21, median is 21. So our mean equals our mode equals our median. So that means that we have a normal curve. Mean is 5, mode is 1, median is 2. So our mean is greater than our median, which is greater than our mode. What that means is that our mode, our highest frequency, is one of our lower values. And then it goes down from there. So this is right skewed. So getting familiar with the graphs is really important to help you understand this different language. All right, let's consolidate what we've learned today. So we've been looking at lesson 18, which is data distributions. We first looked at histograms, which are like bar graphs, but they have touching bars because the data is continuous. So we show our data using frequency in intervals. So that interval piece is really important. Our normal distribution is when we're symmetrical around the mean. Our bimodal distribution is when we have 2 peaks or 2 modes. Our left skewed distribution is when we have a tail on the left side and a peak on the right. This is when our mean is less than our median, less than our mode. Our right skewed distribution is when our tail's on the right side and we have a peak on the left. This is when our mean is greater than our median, which is greater than our mode. So hopefully with our success criteria, you can create a histogram using intervals and frequency tables. And you can explain the differences between normal, bimodal, skewed left, and skewed right distributions. So if you have any questions or concerns, please, as always, reach out and connect with me. I'm here to support you however I can. Give me a call at the office at 807-737-1488, extension 2209, or toll free 1-800-667-3703. Send me an email at bronwyn.slate@nnec.on.ca or a Facebook message at bslatewahsa. Remember, my YouTube channel is also called bslate Wahsa, and you can find all of our previous lessons as well as this lesson up in a playlist called MBF3C. So everything is there for you to support you however you need to use it. Thank you so much for joining me today. I hope you have a lovely day, and miigwech.